Throughout the history of paleontology, there have been few debates as long-running and potentially heated as those involving the tyrant lizard king. Amongst this discourse, one debate stood above many in a class all its own. In the final days of the Mesozoic, did Tyrannosaurus reign over its North American domain alone as the last and greatest of the tyrannosaurs, or did another enigmatic heir to the tyrant reptile legacy stand short in its own way? Nanotyrannus was a name that once invited chaos and sparked division at the mere mention of it for decades, but it might now go down in history in a whole different way. So, how did we get to this point? A point at which, right before Halloween 2025, a seemingly long-buried genus of dinosaur came clawing its way out of its taxonomic grave. I know I've said countless times in my other videos that I don't really ever want to touch the Rex v Nano debate, but now is the perfect time to, considering what has been discovered. To figure out the mystery currently unfolding in front of our eyes, we must first take a trip back in time. Not to the Cretaceous, my friends, but just back 83 years, and to the Badlands of Carter County, Montana. During a 1942 expedition to further explore the late Cretaceous geologic formation known as the Lance Formation, on behalf of the Cleveland Museum of Natural History, paleontologist and fish guy David Dunkle discovered a peculiar, almost 2-foot-long skull of a carnivorous theropod dinosaur eroding from what they used to call the Hell Creek member of the Lance Formation, but what is now considered the full Hell Creek Formation. Dunkle would go on to be honored with the name of the giant placoderm Dunkelosteus, just FYI. This theropod skull would be described in a 1946 Smithsonian published paper by Charles Gilmore as a new species of the then already known genus Gorgosaurus, specifically naming it Gorgosaurus lancensis, with the species name in reference to the now incorrect assignment of the skull to the Lance Formation. That would pretty much be it for this thing, with only experts knowing about it for the following 42 years. In August 1988, the specimen was redescribed by a trio of paleontologists that many from the 90s and 2000s would no doubt recognize. Robert Bakker, Michael Williams, and Phil Currie published a paper in the now-defunct Hunteria Societas Paleontographica Coloradensis journal, taking a more in-depth look at that old skull described in 1946, housed at the Cleveland Museum. Interestingly, they also took a look at an assortment of strange, blade-like teeth that had been found in 1924 in the same geologic formation as the Gorgosaurus lancensis skull that were then accessioned in the collections of the Denver Museum of Nature and Science. These teeth were found alongside those definitively belonging to a small Tyrannosaurus. Specimen CMNH 7541 seemed to retain many traits that separated it not only from Gorgosaurus, but all other tyrannosaurs known at the time, and therefore needed to be upgraded to genus level. The team rebranded it as Nanotyrannus lancensis, the dwarf tyrant of the lance. Nanotyrannus seemed to contain a combination of primitive and advanced anatomy. Bits and pieces seen in earlier forms, as well as bits seen in more evolutionarily advanced forms, such as Tyrannosaurus. One was that the snout was 1/4 the width of the back end of the skull. This feature is only seen in as extreme a way in Tyrannosaurus. An odd and broad feature that sets it apart from the advanced tyrannosaurs, and is more similar to forms like Alioramus, is that its snout is definitely much less robust than forms belonging to the Tyrannosauridae family. The teeth of this proposed Nanotyrannus are much more flat, side to side, than the rounded railroad spike teeth of the Tyrannosaurids. One of the anatomical features that set it apart from most other tyrannosaurs was the lack of strong ridges, striae, and rugosities along the top of the skull. The slim-snouted Mongolian Alioramus is famous for having 5 to 6 hornlets along the snout, and Tyrannosaurus had chunky rugose crests around the eye socket. Nanotyrannus does have a little bit of waviness going on along the nasal bones, and does have some pointy bits on the lacrimal bones, but they don't really resemble the same bone texture in other tyrannosaurs. Nanotyrannus also has a neck configuration and binocular field of view most similar to Tyrannosaurus, so it offered some interesting implications for the evolution of these animals. However, due to such a hodgepodge of features, including ones not seen across the entire Tyrannosaurian group, the 1988 paper considered most of the similarities to the advanced members of the Tyrannosauridae a result of convergent evolution, when two distantly related lineages evolved similar structures. Nanotyrannus largely went under the radar for a good portion of the 1990s until the end of the decade and start of the 21st century, when a few scientists decided to take a different approach to Nanotyrannus. Journey to Synonym. Thomas Carr is a vertebrate paleontologist renowned for being one of the world's few tyrannosaur experts. I mean, there's probably a lot if you include people that work on other animals as well as tyrannosaurs, but the most well-known are usually Phil Currie, Dave Hone, Thomas Holtz, Pete Larson, and somehow Jack Horner. In 1999, Carr published a paper in which he hypothesized that Nanotyrannus was not a valid genus or species and instead represented the juvenile form of Tyrannosaurus rex. I will go into more detail about this major point in tyrannosaur research really soon, but a lot of people don't know that Carr wasn't the first to come up with this idea. Rozhdestvensky, 1965. Anatoly Rozhdestvensky, a Soviet paleontologist active during the first half of the 20th century, was the guy responsible for reanalyzing the many tyrannosaur specimens known from Mongolia, resulting in the name Tarbosaurus. Let me backtrack real quick on you. The Asian cousin to Tyrannosaurus, Tarbosaurus, was originally discovered in the late 1940s and described in the mid-1950s by Evgeny Malayev, also the guy who described Therizinosaurus as a turtle, just FYI. He considered it so similar to Tyrannosaurus that he named it as a new species to this old genus, Tyrannosaurus bataar. At the same time he made this name and defined it, he also came up with Tarbosaurus ephremovi, Gorgosaurus lancinator, and Gorgosaurus novogelovi. Decades later, Rozhdestvensky came back to these specimens and found that they did not contain enough differences to validate their existence, and so he synonymized them all together, resulting in the combination of Tarbosaurus bataar. In this 1965 paper, Rozhdestvensky noted a few similarities and differences between the juvenile and adult Tyrannosaurus specimens he was combining into one species, and then made the same comparison between Tyrannosaurus and what was then Gorgosaurus lancensis. As Rozhdestvensky puts it, this would mean it's possible that Gorgosaurus lancensis is actually the juvenile form of Tyrannosaurus rex. This is then the basis upon which Thomas Carr begins his 1999 paper, furthering the case that these two dinosaurs, now having two unique labels, are actually one and the same. Carr, 1999. 1999 saw Thomas Carr publish a paper in the Journal of Vertebrate Paleontology, in which he takes a look at a bunch of Albertosaurus skeletons of different growth stages, the Cleveland Museum skull holotype of Nanotyrannus, and the growth stages of Tarbosaurus, in order to find out what the hell was going on. Carr found that Albertosaurus morphs from a slender juvenile with immature bone texture and very long legs with roughly similar tibia to femur lengths into a robust adult with rugosities all over the skull and a longer femur. Obviously, the Nanotyrannus holotype is just a noggin, so Carr could only compare the skull bones to those of younger Albertosaurs. He noted that the arrangement and anatomy of the individual skull bones, lack of fusion in some of those bones, the gracilness of the bones, and the larger number of teeth all meant that the Nanotyrannus skull was a juvenile and fairly normal in development for juveniles of more advanced tyrannosaurs, like Albertosaurus and Tarbosaurus, both of which come from two major sides of the Tyrannosaur tree, the Albertosaurines and the Tyrannosaurines, as part of the Tyrannosauridae. One seemingly insignificant trait here is the tooth count. Carr found that young Albertosaurs had more teeth than adults. His hypothesis was that the skull bones changed so drastically as the animal aged that the tooth count could shift as proportionally larger teeth crowded out some smaller tooth sockets. Keep this in mind as I move forward. Jane, 2001. Carol Tuck and Bill Harrison, while on an expedition to the Hell Creek Formation of Ekalaka, Montana, with the Burpee Museum of Rockford, Illinois, led by Michael Henderson, discovered the remains of a small tyrannosaur of some type eroding from an outcrop. Once it was brought back to the museum and prepared, researchers knew it was something incredibly special. Though far from complete, this small tyrannosaur preserved enough of its skeleton, and more importantly, its skull, to immediately bring up comparisons to the Nanotyrannus skull that had been sitting around without a new label the preceding 13 years. Specimen BMRP 2002.4.1, aka Jane, prompted a conference to be held at the Burpee Museum of Natural History in 2005, inviting every tyrannosaur expert in the US to weigh in on what the hell this thing was. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.